Welcome back to this video sessions on data engineering. In the last session, we ran the pipeline as a job, and this is the output that we got. In this video, we are going to see the output, the results of this output. The first thing that will go in the score model, and in the score model, if you see the preview data, you will see that the model has provided these code levels, which is basically the prediction of the model. We all know in any classification system, the output is actually a probability, and then you have a cutoff of 0.5. Usually, that's the normal industry standard. And if the cutoff is, if it's more than 0.5, then it belongs to one class, and then the probability is less than 0.5, it belongs to another class. So in this case, you can see if where the probability is more than 0.5 is belonging to the class greater than 50K, and if the probability is less than 0.5, then it's belonging to the class less than equal to 50K. And you can see that already some classifications are incorrect. For example, the first classification itself is incorrect because actual value is 50K, whereas it has been classified as less than 50K, whereas it has been classified as more than 50K. But you see the other ones which are correct. So we need to find out an overall summary of how many correct classifications have been done by the model. And in case of any classification problem, the most popular metric that is used is called confusion metric. So we'll see the confusion metric, right click over here in the evolution and preview the data. And so we'll come back to this ROC curve, but before that, this is the confusion metric. So what we're saying, this is something that you have probably learned in your machine learning course. You have this actual and if you have this predicted. So there are 1,518 cases where actually the data shows that the income is more than 50K and the model has correctly predicted that the income is more than 50K. So we call this true positive class. So initially, when you are defining the classification, you need to define which is considered as a positive class and which is considered as a negative class. So in this case, the positive class is considered to be greater than 50K and negative class is less than equal to 50K. So we see that there are 6,381 cases where the income is less than 50K and the model has also correctly predicted the income is less than 50K. So it's 1518 and 6381. These two are correct prediction or correct classification by the model. However, you see there are 415 cases where actually the income is less than equal to 50K, but the model has predicted more than 50K. So these are incorrect classification. So since the class less than equal to 50K is a negative class, the prediction is positive greater than 50K. This is considered to be a false positive case. That means the model has predicted falsely that is a positive class, whereas actually it's a negative class. Similarly, there are 734 cases where actually the income is greater than 50K, but the model has predicted that income is less than equal to 50K. Since the model has predicted it to be negative, this is a false negative case because the model has falsely predicted it to be negative. Now there are a few important metrics. The first metric is called accuracy. And you can see the accuracy is 0.873 for the model. Not too bad, but we actually didn't do any pre-processing. We didn't do any hyperparameter tuning until we got a result of 87% accuracy, which is not very bad given the simplistic model that we have built. Now, what does accuracy mean? Accuracy means that out of the total cases, how many cases has been correctly classified? That means this will be equal to 2 positive plus 2 negative divided by 2 positive plus false positive plus 2 negative plus false negative. So this is 1518 plus 6381 divided by 1518 plus 6381 plus 415 plus 734. Then you have something called precision. Precision means that out of the cases that the model has correctly predicted, model has predicted to be positive, how many of them are actually positive? So how many does the model predict to be positive? 1518 plus 415. And how many of them are actually positive is 1518. So precision is 1518 divided by 1518 plus 415. What is recall? Recall is the other way now. Out of the total cases of positive, how many have been predicted correctly by the model? So what are the total cases of positive? 1518 plus 730. How many have been correctly predicted by the model? 1518. So it's 1518 plus divided by 1518 plus 734. That is the recall. Now, why these two measures are important? Because of two reasons. The first reason is that the cost of misclassification is not is not symmetric. That means the cost of a false positive may not be the same as cost of a false negative. One may be more expensive than the other. Now, this is a relatively simple example where we are trying to predict the income. We don't know what exactly the use, and hence we don't know what can be the cost elements here. But let's say it's you are trying to predict a customer churn, and say churn is a positive class. So a false positive would be those cases where the model has predicted that the customer the customer will churn, but when the customer does not churn. Okay. Now, what is the cost involved there? Now, if the customer, you know that the customer is churning, you may want to retain the customer by giving some, let's say, offers or some other incentives. So there's a cost of that incentive. But those cases where the customer will not churn and you thought the customer is going to churn, these incentives are wasted. That's the cost. On the other hand, false negative cases are what? Those are the cases where customer will actually churn, but the model predicted they will not churn. So there will be no effort on your part to retain them because you think that they will not churn. So you will not spend anything on the offer, but on the contrary, you may lose that entire customer, and there will be a cost of the entire lifetime value that the customer is bringing. Or if you have to replace that customer with an alternative customer of similar lifetime value, there is an acquisition cost of a replacement customer. Now, these two costs may not be the same. Okay. That's number one. Now, you may say that, okay, why can't we reduce both of them? The problem here is that, and I'm not getting into the mathematical reasoning of why it is so, if you want to reduce the false positive, false negative will go up. And if you want to reduce the false negative, false positive will go up. I'm sure these kind of things you have studied probably in your statistics classes. So you cannot minimize both. So you have to figure out which one you should minimize depending on what is the cost. Okay? And that is the reason why precision and recall are important. There is another data point which is called F1 score, which basically says that if we have to balance precision and recall. So F1 score means is equal to twice the precision, 2 times precision, 2 into precision into recall divided by 2 multiplied by precision multiplied by recall divided by precision plus recall. So that is what F1 score is. So if you have to get a balance, suppose I want to get an optimum balance of precision and recall, then in that case I may go for F1 score. Now, what is AUC? AUC is the area under the curve. Now you come to this ROC curve. ROC means receiving operating characteristic curve. Now, this area under this receiving operating characteristic curve shows how accurate the model is. Higher the area, more accurate the model. Now, what does this ROC curve mean? ROC curve plots false positive rate versus true positive rate. So, and it plots this graph against the cutoff values. So if you, for example, say that the cutoff of positive is 0, that means anything above 0 probability or anything equal to or above 0 probability, you are going to classify as positive. Then what is going to happen? Everything will get classified as positive. Okay. So your true positive rate, which is your the actual positive divided by what you predicted as positive, will become 1. Okay. And your false positive rate, that means those cases where you have predicted that it is positive, but actually it is not positive, that also will become 1. So everything you have predicted as positive. Opposite will happen if you consider the cutoff to be 1 instead of 0. So zero point 0.5 shows if you have a cutoff, the 0.5 will be somewhere here. So you can see here 0.5 is somewhere here. Okay. So if you have a cutoff of 0.5, what will be a true positive and what will be a true or false positive rate? Again, you cannot minimize both. If you have to minimize one, other will also get minimized. Okay. If you maximize one, the other will also get maximized. So the important thing here is that you try to find out whether zero point 0.5 is the right cutoff value. So here you can see that as I change this, these numbers change, confusion matrix changes. Now this helps you to, and depending on the cost of misclassification, this helps you to decide whether I should take a cutoff at 0.5 or I should take a cutoff at some other value. This is the purpose of the ROC curve. Again, these are machine learning subjects in machine learning. I'm just repeating it here just to tell you the purpose of this. But if you want to know more details, it's best to consult any machine learning books on this or courses on this. Okay. So this is how we have built the model and built the pipeline, and we have analyzed the outcome of the pipeline. In the next video, we are going to see how we are going to deploy the pipeline.